in calculus language, one of you already said this, in calculus, I didn't want calculus language until now, so, but in calculus language, what does that, something is slowing down when what? The velocity and the acceleration, or force, are in opposite directions. Now, doesn't that make sense? All right, so if you could visualize, this is the carpet floor, but suppose we had one of those, and our chairs don't roll around here, but suppose we had a chair that was on casters, and this was a slick tile floor, and one of us was in that chair just flying across the floor, and somebody else got behind them and started pushing. What would happen? They would speed up. Okay? Get the picture now. If somebody was in, what maybe me, big, is in that chair, and I was flying across the floor, and one of you little scrawny women jump out in front of it and started pushing, well, I'm going to, I mean, I'm big, that dinner good. I'm going to sort of run over you, right? I mean, you're pushing that direction, and I'm traveling that direction, so what's going to happen? I'm going to slow down. Okay? All right. Well, what we can do here to answer these two questions real easily is combine these two split line graphs. Okay? So I'm going to make one split line graph with all of these special values on it. 0 to, what's the, is 6? Yes. 10 and 15. Okay? Then I'm going to put these two together. So here's the velocity. I've already done it. But, so from 0 to 2, velocity is what? Positive. From 2 to 6, what's the velocity? Negative. From 6 to 10, what is the velocity? Negative. And then 10 to 15, what's the velocity?
Positive.
Okay, right above that, let's do the acceleration. Here it is. So from 0 to 2, what do we have? Negative. From 2 to 6, still negative. And then positive, positive. Okay? All right, let's see if our answer is consistent with this split line graph. Are these two answers consistent with that? How about slowing down from 0 to 2? Look what happens here. Isn't that what y'all just said? Velocity and acceleration. The velocity is positive, acceleration is negative. Think about that problem here, right? In the context of the problem. From 0 to 2, what's happening? The trailer is moving to the right. I'm pushing to the left. Also, from 6 to 10. That happens over here, by the way. What's the deal there? 6 to 10, the velocity is what? To the left, the trailer is moving that direction, but now what happens? Wayne is pushing in that direction. Okay. So he's slowing it down. All right. Any questions? All right, number 8. What's number 8? What is the total distance the trailer traveled during the 15 seconds? The total distance the trailer traveled. Now this is another reason why I do Crazy Wayne, but there are probably some better situations for this. But let's see. Let's see. Here is the crossroad. And so like right here where how about the distance from here to the ditch? The distance from when the problem started, when the problem started until it fell over the ditch. Isn't that what we're looking for? No. There's another word for that. That's what? Displacement. We want to know what? The total distance traveled. Okay? So I'm going to do I'm gonna do, I'm gonna make a little chart here, whatever, of all the values that we need. And what are they? What are the important values here? Certainly, when the problem started and when the problem ended, what else is going to impact the total distance? When it turns around, when the trailer turns around, okay? So, what I want to know is x of 0. Now, how could you describe what x of 0 is? That is that's right, that's the initial position. All right, x of 2. Now, in the context of the problem, what is that? X of 2, that's when I finally got stopped. Okay? How about x of 6? Do I need to include that? If I do, it's no problem, but the trailer does not stop at x is equal to 6. The trailer is moving to the left, and it keeps moving to the left. Got me? All right, so the next number I need is what? X of 10, and then finally, x of 15. Let's look at these numbers right here. Okay, you can get them. I think I got them. X of 0 is what? 72. What does that mean now? What does that mean in relation to what Danny did, how he set it up? Just means like he just decided to let 72 be the position at the crossroads. Okay. All right, then x of 2 is 128. X of 10 is negative 128. And then x of 15 is 297. Anybody got those? Not good. Verification. All right, so what are we going to do with them now? Define the total distance. Add these.
Find the difference between each.
Okay. Yeah, be careful. Yeah, be careful, be careful. So what we're going to do is find this difference. Okay? So what that'll be is how far the trailer traveled from the time that the problem started until what? I got it stopped. So subtract those two. Take the absolute value, subtract those two, and I think you get 56. Be careful. Got me? All right. Find the distance here. We will learn when we, especially when we get into area volume, that we can just say we're going to subtract this. Big minus small. Biggest minus the smallest, and you'll always end up with a positive number. So anyway, I got to have a positive number. Distance is positive. So that is 256. And now the distance here is going to be huge. That is what? 425. All right, so what do we do here? Add them up, and you get 737. Good? So what is that the answer to? What question? Number 8. Number 8, that is what? The total distance traveled. Okay? Are we good? Is everybody good? By the way, just by the way here, a little bit of an offshoot here. Somebody find V of 6. No. What is X of 6? Find what X of 6 is.
0.
0. You know why that's makes sense now? What happened at 6 seconds? What happened? What event happened at 6 seconds? I stopped pushing. Wayne started pushing, right? Why did Danny set this up where this position is 0.
Straight for the house.
That's where Danny was. Right in front of the house. Isn't that cool? That Danny, he's so smart. All right. Okay. Does that make sense? We're gonna let them meet these guys. All right. That's 8. Now number 9. What's number 9? When is the velocity of the trailer decreasing? Now this, you gotta be careful. Oh, you gotta be careful. This is a quantity. This is not like speed. This is not when it's speeding up, the trailer's speeding up, or when the trailer's slowing down. This is when the velocity is decreasing. Is that what it says? All right. One hard, fast deal here now we've said. If any quantity, I don't care what it is, velocity, weight, volume, profit, whatever it is, if that quantity is decreasing, what do we know? What can we take to the bank? The derivative of that quantity is negative. All right, so to answer this question, when is the velocity decreasing? When is the velocity decreasing? What have I got to do? How can I answer that? I need to know when what? Acceleration is negative. Now that's easy. What is it? So the answer to that, this is number 8 right here. Number 8 is 737, correct? All right, so number 9, this is easy. When is the velocity decreasing? That's from 0 to 6. All right, now listen to this. That is, I think that's sort of tough to understand in the context of the problem. I think that's really tough to understand. So I want to do this. Over here on like scratch paper. Over here on scratch paper. This is what my scratch paper used to look like. Not anymore, but used to look something like this. I'd draw some play, whatever. And then this is what my scratch paper used to look like. So this is scratch paper. I want to do this. I want to find V of 0, and I'm not going to include all the numbers from 0 to 6. You know all the numbers between 0 to 6, right? 0, 1, 2, 3, 4, 5, 6. I may have left out 1 or 2, right? Like I left out pi, and I left out 3.8274, right? So, you know, for the kids, if I'm doing, oh man, I'm not going to say 0, 1, 2, 3, 4, 5, 6. I'm going to say 0, and then how about 1.2? I need your help with the calculator. V of 3.7, V of 4, V of 5.31, and V of 6. This does not prove it, but let's just see what happens. V of 0. All right, V of 0. I'll do that one. I'm pretty good at that one. That's 60, isn't it?
You said V of 0.
V of 0.
6.
Right.
V of 0, is that 60?
Yes.
All right, how about V of 1.2? Anybody got that?
21.12.
21.12. V of 3.7. How much? Negative 32? Point what? 13. Is there some value? You know what? I should have. How about if I insert V of 2? We know what that is, right? What is V of 2? 0. I should have inserted that one. Should have included that one. How about V of 4?
Negative 36.
Negative 36. V of 5.12.
Mean 5.31.
Negative 5.31.
Negative 46.5717.
5717. All right, V of 6.
Negative 48.
Negative 48. Look at the velocity. Look at this velocity, y'all, from 0 to 6. Look at it. What's happening to these numbers? Are they decreasing? That's pretty cool. Okay? that sort of, I didn't prove it, but that just sort of bears out. Of course, we know any quantity that is decreasing, that quantity's derivative is negative. Okay, and so we knew that. Now, let's do one more. How about B of 7? Don't do it yet, don't do it yet, don't do it yet. I'll tell you this, if B of 7 is not bigger than negative 48, if B of 7 is not bigger than negative 48, we're going to call the rest of the class off.
Okay, let's see.
What is it?
Don't you mind?
Negative 45. All right, so what happens after 6? What happens to the velocity after 6? Start increasing again. See that? Does that make sense? Are we good? Are we good? Okay. All right. When is the position increasing? Let's hurry up with this. When is the position increasing? What? That's simple, right? That's when what? The derivative of the position is positive. What's the derivative of the position? Velocity. And the position is increasing. Hey, how about in the context of the problem? In the context of the problem, when is the position increasing? Anytime
Tracker goes to the right.
the trailer. Anytime the trailer is moving what? To the right. Okay? And now when is the trailer moving to the right? From when to when? 0 to 2. You to start with, the position is increasing. And then also from what? 10 to 15, the position is increasing. Okay? Now, finally, when and where does the trailer attain its minimum position? Do I have all the information on the board to find that? All right, this is an optimization problem. How do we do optimization problems? We are going to do what? Identify all the candidates, have an election. All right? Now, what are the candidates here? All of the candidates that are running for the office of minimum position for this trailer. What are they? 0, 15. Those are the important. What else? 2 and what? 10. Hey, we already had that election, didn't we? We already had the election. So, what is the minimum position? Be careful, it's not Monticello. Well, yeah. What is it? Negative 128. And when did that happen? At 10 seconds. Okay? Is everybody good? Everybody good?